Hi, today in Lesson 7 we are going to be talking about associated ratios and the value of a ratio. Before we begin, let's talk about what the value of a ratio is, and there's a definition that we're going to write down, you in your document, in your book, and myself, I'm going to type it right in for you. Okay, so the value of a ratio is the quotient of the two parts of a ratio. I'll explain that a little more in a few minutes. The quotient is the answer to a division problem, something else you're just going to want to keep in mind. Okay, we're talking about the value of a ratio. Okay, so let's go ahead and look at the first problem. Our classwork example 1 is, which of the following correctly models that the number of red gumballs is 5/3 the number of white gumballs? Well, the first thing we probably want to do is look at all these tape diagrams and decide what the ratios are for these tape diagrams. Our first tape diagram has 3 red gumballs, so we write the number 3 to 5. Because that's our ratio. Red is first and white comes second, so our numbers work out. Our next one is red to white. We have 1, 2, 3, 4, 5 red, 2, 3 white, 5 to 3. C says 3 to 2. And D says 5 to 1, 2, 3, 4, 5, 6, 7, 8. So 5 to 8. 5 to 8. Sorry about that being crazy. So looking at our definition of what the value of a ratio is, the value of a ratio is the quotient of the two parts of a ratio. The quotient is the answer to a division problem. So if you remember, we had a fraction bar in the past. The fraction bar was like that. The fraction bar, believe it or not, is not just called a fraction bar. When we have a number above it and a number below it, we have the numerator, remember that, and the denominator. Well, something else that the fraction bar means, besides just the divider between the numerator and the denominator, is it actually means divided by. So when you have the numerator above the denominator, what you're really saying is the numerator divided by the denominator. And whatever those numbers are is the numerator, whatever that number is, divided by the denominator. So that's important because we talk about the value of a ratio. It's the quotient of the two parts of a ratio, and the quotient is the answer to a division problem. That's where this comes from. So let's apply it now to our numbers. The first number in our ratio is the numerator, and the second number is the denominator. Right. So if 3 is the numerator and 5 is the denominator, then when we put an equal sign, this means that 3/5 is our fraction. It's our ratio, written as a fraction. Okay, so if we have 3 to 2 as our ratio, then 3 is the numerator, 2 is the denominator, and that equals 3 over 2. So you see, it's not really that hard to understand. It's just a different way of writing ratios in the form of a fraction. B is equal 5 to 3. And 5 is the first number, so 5 is the numerator. And 3 is the denominator. D is 5 to 8, so 5 is the numerator. And 8 is the denominator. So now that we have them, I've kind of rewritten them a little bit easier to try and make it a little neater. Now that we have the ratios and then the value of the ratio, which is the fraction, for each one of these, we can go back to our original question, which asks us, which of the following correctly models that the number of red gumballs is 5/3 the number of white gumballs. So you see, once we have it in fraction form, we can go back and read it as if it's a fraction, because it is a fraction now. And that's clear to see that B is the correct answer, because that has 5 red gumballs and 3 white gumballs, and that is 5/3. And so that is why the answer is B. Not too bad. Let's move on to the next one. Okay, well, in example 2, we have the duration of 2 films that are modeled below. This is actually a straight line here that closes it off. It just for some reason didn't come on there correctly. So we have film A, which is a film that was made, and film B. The tape diagram shows us the length of the films. Now, we can say that film A is not quite as long as film B, because we're talking about the duration. Duration refers to how long the movie is. But let's talk about the parts in film A. In film A, in our tape diagram, we have 1, 2, 3, 4, 5 parts. So let's write that down. 5 parts. Sorry about my writing here. This program is kind of weird. In film B, we have 1, 2, 3, 4, 5, 6, 7 parts. And they may look different, but we can assume that they are the same size. And that's important when you're working with ratios, that we know that the parts are the same size. If we were to talk about the whole in this situation, we would have to talk about all of the parts included in both film A and film B. And so the whole would be 5 plus 7, which we also know to be 12. Sorry. So I'm going to write the whole down here, just so that we keep that in mind when we talk about all the parts. Would be 12. We may not need that number right now, but we might need it later on. So A says the ratio of the length of film A to the length of film B is, well, that's easy. Film A was the first part of this ratio, so that's 5. And film B was the second part, and that's 7. So it's 5 to 7. So we can answer that no problem. Now, they want us to write the ratio as the value of the ratio, and they want us to write it as a fraction form. Well, we learned just a few minutes ago that the length of film A is, the numerator would be the first number, and that's the top number, 5. And the denominator would be the second number, and that's 7. So the length of film A is 5/7 of the length of film B. And note that the of, very important, that the of refers to multiplication. And that might come into play a little bit later on, but don't forget that the word of refers to multiplication. All right, I'm going to move down. I'm going to erase this part, and then let's move down a little bit. C. Let's go back and put the 5/7 in here so that we know what we're working with. So C says the length of film B is what fraction of the length of film A, or what ratio of the length of film A. So if film A was 5/7 when A was first, now all we're doing is switching this. So when we flip-flop it, we need to put the film B first, which was 7, and then film A, which was 5. Now these are not the same ratios. 5/7, as you know, remember from last year, is not the same as 7/5, and that's important to keep in mind. But the order of the words dictates or tells us the order of the numbers. And this is the case here. Now, exercise 1, moving on, reads, Sammy and Caden went fishing using live shrimp as bait. I've never thought about doing that when I went fishing. Sammy brought 8 more shrimp than Caden brought. When they combined their shrimp, they had 32 shrimp altogether. Now we're just simply going to answer the question. So as we go to answer the questions, I'll probably pause the video so that you can take time to answer them in Edpuzzle. How many shrimp did each boy bring? Well, when we start talking about how many shrimp each boy brought with them, let's start with what we know. We know that there were 32 altogether. We know that Sammy brought 8 more shrimp than Caden, so Sammy was, when we represent more, we use the sign addition, the sign of addition. So 8 more than Caden, and we're not sure how much Caden brought. So we can't fill in this K. Notice I'm using letters to represent the boys' names as opposed to blanks. These are called variables, and it's just another way of having a blank. I just have it written so that we can distinguish between which blank from the other. So we have 32. We know that Sammy has 8 more than Caden, and we don't know how many Caden has. So let's try a guess and check method. Okay? If we took 8 from 32, we'd have 24. But that wouldn't be an accurate amount, because if we put 24 here, because that would fit here, 24, and we'd have to put it here, then we would end up with much more than 32. We'd have 32 plus 24, which is 56. So that's not going to work so much. What if we decided that Caden brought 10, and so then Sammy would have brought 10 plus 8. If 10 plus 8 is 18, plus 10 more, that's 28, not our 32. So what I'd like you to do now is what I've been doing, guessing and checking. Put numbers in here until it works out that this plus this one plus this one is 32. And whatever we put here for K has to be for K for both of them. Okay? Give it a minute, see what numbers you come up with, and I'll come back and have the answer. Alright, so here's what the answers are. If Sammy equals 8 more than Caden, and if Caden brought in 12, then Sammy would bring 8 plus 12, which now equals 20. And the reason we came up with this was 8 plus 12 is 32. Remember, if we took 8 from 32, we had 24. If we just broke that into 2, that's where our 12 comes from. So our final answer is Sammy has 20, sorry. Sammy brought 20, and Caden brought 12. All right, I'm just going to move this up a little bit now. Okay, so when we're talking about the number of shrimp, B says, what is the total number of shrimp Sammy brought to the number of shrimp Caden brought? So let's go ahead and write in our information over here. I'll write it over here. Sammy, he brought in, if you remember, 20 shrimp, and Caden brought in 12 shrimp. So those are the numbers we're working with. We don't want to forget about those numbers. Let's make them nice and big for us. So when we're talking about the ratio of the number of shrimp Sammy brought to the number of shrimp Caden brought, what is that ratio? Ratio is 20 to 12. So that's easy enough. We could do that. C is asking us now to express this number of shrimp that Sammy brought as a fraction of the number of shrimp that Caden brought. So what that means is they want us to write the value of this ratio, and they want us to do that by writing it as a fraction. So go ahead on your own and type in. When you write a fraction when you're typing it, it looks like the numerator and then that sign and then a denominator. That's when you're doing it when you're typing. The line isn't directly across. So when you're asked to do it on Edpuzzle, that's what they're looking for. So I'm going to do it the same here, but I'm also going to write it in for us as well. Very nice. Now, the numerator would be the first number, and so that would be 20. And here's our fraction bar. and our denominator is 12. So if I wanted to show you that in written form the way we're used to seeing it, it would look like this. 20 over 12. And you want to be familiar with both of these, because sometimes you'll be expected to write it this way with the fraction bar right under it, and then the denominator right under that. And other times you'll be expected to write it this way where you have to type it in. I want you to be able to recognize both of these as being the same. They're just viewed a little bit differently. So that was our fraction. So B is a little trickier because it asks what is the ratio of the number of shrimp Sammy brought, that's our first ratio, to, there's our clue word there, the total number of shrimp. So now you have to go back and look at the very beginning and see what the total number of shrimp was. Go ahead and do that now. Well, the number of shrimp that Sammy brought was 20. And then here comes our fraction bar. And the total number of shrimp, if you remember, if you look back, was 32. Looking again, what fraction of the total shrimp did Sammy bring? So now we've got the total shrimp comes first, and then Sammy comes second. So that's just this number written opposite. And this one I'll write this way. The total number would be the numerator, and the number that Sammy brought would be the denominator. And so that's our fraction. And to write this as typing it, it should have looked like this. And now I've made it big so we can see it clearer. Exercise 2. A food company that produces peanut butter decides to try out a new version of its peanut butter that is extra crunchy using twice the number of peanut chunks as normal. The company hosts a sampling of its new product at grocery stores and finds that 5 out of every 9 customers prefer the new extra crunchy version. Okay, so before we do anything else, let's talk about what's going on here. There's a food company and they make peanut butter. And apparently they decided to make an extra crunchy version of peanut butter. So I'm going to go ahead and underline that. And when they make that, they use twice the number of peanut chunks as normal. That's not really important. What's important is that they have an extra crunchy peanut butter now. So the company has this host of sampling. People can go and sample it. And they find that 5 out of every 9 customers prefer the new crunchy version. So there are 2 versions. There's the new extra crunchy version and the old version. So now that we have that, let's talk about what we need to do. Let's make a list of ratios that might be relevant for this situation. Okay? The ratio of number preferring new extra crunchy to total number surveyed is, well, before we do that, we have to think about what are we talking about when we say the total number surveyed. And let's go back to our ratio. 5 out of every 9 customers. Do you remember, I believe it was in the last lesson or the lesson before, when we talked about the different types of ratios where they are part to part or part to whole ratio? This one is a part to whole. So I'm going to put that over here. A part to whole. When we say part to whole, when we talked about the number that Sammy and Caden had in the last example, altogether they had 32. But when we're talking about part to whole in this way, when we're talking about it in the ratio, we're referring to 5 and then another part and then 9 being the whole, because this was 5 out of every 9 customers. So 9 is our whole. So if 9 is our whole and 5 is one of the parts, what might the other part be? The other part would be 4. So if we have 5 out of every customers that prefer the new crunchy version, 5 like the new, How many then would like the old? If we have 9 altogether, that's got to be 4. 4 like the old. Okay? And let's, just so that we know what we're talking about, let's go ahead and give these a new color. Let's call them my favorite pink. All right, so that's information we need to have figured out from this. So now, go back to our AI. The ratio of number preferring new extra crunchy to total number surveyed is, if they like the new one, that would be 5 to 4. That's our original one, 5 out of every 9. Sorry, 5 to 9, because they didn't want to know the ratio of new to old. They want to know the ratio of new to total number. So it would be 5 to 9. Okay, we can do that. 5, and here's our colon, to 9. Moving right along. The ratio of number preferring regular crunchy to the number surveyed. Well, the new is the new crunchy, so the old must be the regular crunchy. And let's make sure that we're clear about this. This would be the extra crunchy. And so the old would be the regular crunchy. Okay, so now we can figure this out. The ratio of number preferring regular crunchy to the total number surveyed would be, well, we figured out that 4 like the old or the regular crunchy. So we'll put the 4 here because that's what we're supposed to put first. And then the total number surveyed we know is 9 from our previous one and from what it said in the problem. So that would be 9. All right, we're doing pretty good. Triple I says the ratio of number preferring regular crunchy to the number preferring new crunchy is, if we come back and look over here, regular crunchy to the new crunchy, it would be 4 to 5. All right, the ratio of number preferring new extra crunchy to the number preferring regular crunchy now would be 5 to 4, because the new extra crunchy is right here, new extra crunchy, to the number preferring regular crunchy, and we figured that over here, regular crunchy. And you see how writing it down here and specifying new and specifying extra crunchy and then old and regular crunchy helped us to figure out the words that they chose to use to describe it. So always looking at the information that the problem gives us and thinking about it and rearranging it and kind of making sure as we've written it out really helps us when we're answering some of these questions. Okay, now part B says let's use the value of each ratio to make multiplicative comparisons for each of the ratios we described here. Now don't be caught up on the words. The value of each ratio we've already learned means we're turning the ratio into a fraction. Multiplicative means that they have the word of in our sentence. And that's it. Don't let it freak you out. The number preferring new extra crunchy is blank of the total number surveyed. So that's how our fraction is going to be. The number preferring new extra crunchy is where our numerator goes, and the total number surveyed will be our denominator. So now that we know that, you can just fill in the information. Okay, so the number preferring new extra crunchy would be 5. I'll put that up here first. And the total number surveyed was 9. Remember, that was our whole. Now I wrote it the way that you write it if you're typing it on the computer. But if that's confusing to you, it looks like this. So if you're writing it on paper, you can just write it like this. Again, I want you to be familiar with both of those. All right, looking at the next one, the number preferring regular crunchy is in some fraction, the value of the ratio, fraction of the total number surveyed. Okay, The number preferring regular crunchy was 4. And then the total number surveyed, again, was 9. Wow, that 9 doesn't look great. That's better. Okay? The next one. The number preferring regular crunchy is, and here's our fraction, of those preferring new extra crunchy. Well, that one would be 4/5. So that reads, the number preferring regular crunchy is 4/5 of those preferring new extra crunchy. IV, which is the Roman numeral for 4, says the number preferring new extra crunchy is some fraction of those preferring regular crunchy. Well, as you see, I've written this up here so that I just don't lose track of what we're working with. New crunchy would be 5, fraction bar. Regular crunchy is 4. So we've done pretty good so far. Let's keep on moving down. If the company is planning to produce 90,000 containers of crunchy peanut butter, how many of these containers should be the new extra crunchy variety? And how many of these containers should be the regular crunchy peanut butter? What would be helpful in solving this problem? And does one of our comparison statements above help us? Well, we have to look at this whole problem again. And remember that we're talking about these numbers, and let's look at these numbers here. Where'd it go? That 5 like the new and 4 like the old, and there were 9 people, 5 out of every 9 people were the ones that like the new, and 4 out of every 9 people like the old. So we have to just keep that in mind, okay? Then, stop touching things. Then, if we look at this and say, if the company is planning to produce 90,000 containers, so let's stop there. 90,000 containers of crunchy peanut butter is a big number. Do not let that throw you off. We can work with big numbers. How many of these containers should be the new extra crunchy variety, and how many should be the regular? So let's take the new extra crunchy first. What's our ratio for the new extra crunchy compared to the total parts we're talking about? The fraction we had was 5. Where did we go? Here it is. And that's kind of small. Was 5 compared to the total amount, 5 fraction bar 9. So 5 to 9 would be how many we really want to have. 5 out of every 9 should be new. No, we have 90,000. So what can we use to help us figure this out? Well, there's a few things we could do. We could do a tape diagram. We could do 5, and then we could do 9, 9, 5 and 4 together, and we could figure it out that way. Or, so we could do 5 new, and we could do 4 old. Altogether we'd have 9, and then we could figure out of 90 how it fits. You could certainly do that. You could also say, okay, 5/9 of 90,000. That's a lot of peanut butter. Do you see how turning our ratio into a fraction will help us? Now, if you remember how to do fractions, we now can set up a math problem. 5/9 of means multiplication. And so you can write multiplication with a dot of 90 thousand. Now, do you remember how to do multiplication of fractions? You learned it last year. You draw a line under for your fraction bar and you make it 1. That's the same thing. And then you multiply straight across. So I'd like you to try to figure out 5 times 90 and 9 times 1 and work that out here. And then if you don't like doing it this way, use a tape diagram or try and do both. And let's see what answer you come up with. Well, you should have come up with a number 450,000 over 9. And then if you reduce this, which really, remember that our fraction bar means divided by, we then say 450,000 divided by 9, it's actually 50,000. So if 50,000 is the new, it's 5/9, that was a new one. So there was a suggestion that we make 50,000 of the new crunchy. We're making 90,000. What would be the old crunchy? Well, if you chose 50,000 for the new, because that's what we figured out, we have 90,000. We have to have 40,000 left to make old. And if you noticed, 50,000, 40,000, 90,000, they're all multiples of 5 and 9 and 4 and 9. So they made it kind of easy with easy numbers now that you go back and look at it. But when you initially looked at it, you were probably a bit nervous about the numbers. So this is how you do it with a fraction. And remembering how to use our fractions. Now you know why you were taught fractions last year and why you were taught how to multiply fractions. When you take a ratio and turn it into a fraction by using the value of a ratio, you just turn a ratio into a fraction, you find that you can work on it with ways you're more familiar with. Now I didn't talk about the tape diagram for the last one, but if you got the right answer, then you did the tape diagram correctly. I would like you to work on the fraction part of it because that's something that you'll need to know for other problems as well. Okay, D says, if the company decides to produce 2,000 containers of regular crunchy peanut butter, how many containers of new extra crunchy peanut butter would it produce? So again, we're not doing 90 this time, we're doing 2,000. So go ahead and figure it out yourself and see what you come up with for an answer. Okay, so we're trying to figure this one out. We're trying to do another fraction form. Sometimes you might be saying, I don't understand how to do this as a fraction form. So maybe that's not what we need to do. We need to look at what we're trying to figure out. So what I did to help us see that was went ahead and put a tape diagram down. Because that's one that we're all pretty familiar with and probably feel most comfortable with right now. So if the regular was 4, the extra crunchy was 5, we know that they're going to make 2,000 containers of regular crunchy peanut butter. So here's the 2,000 containers. What do we need to do to figure out how many extra crunchy they would make? Well, we do need to take the 2,000 and put it into these parts. To take the 2,000 and put it into these parts, what operation are we doing? We're going to be doing division. So we're going to do 2,000 divided by what number? 4. If you do 2,000 divided by 4, we'll know how many to put in these parts, then we'll also know how many to put in these parts. And so sometimes, even though we're working with fractions as a ratio, it might be better to use a tape diagram to help us understand it. So now you can see, using our tape diagram, that if we divided 2,000 by 4, we would get 500. And you can separate 500 into each part, and then we can separate the 500 into these parts, and we could get together end up with, for extra crunchy, 2,500. The question asked, how many containers of new extra crunchy peanut butter would it produce? And if we had underlined our question, that would have helped us get back to it. Extra crunchy, it would produce 2,500. All right, let's move on to the next. E says, if the company decides to produce 10,000 containers of new extra crunchy peanut butter, how many containers of regular crunchy peanut butter would it produce? I'm thinking you may not even need to do a tape diagram, but some of you may need to do a tape diagram, and that's fine too. So go ahead and do whichever one you need to do. Okay, what you would have needed to do was 10,000 divided by the 5 pieces for extra crunchy. And then you would have had 2,000, and 2,000 goes inside each piece. And then because we know that they're the same size, 2,000 goes inside these pieces, and that's where we get 8,000. If you didn't do it that way, and you just did the math and was able to figure that out, that's fine too. Just remember that you do have to always show your work. And so that was E. Well, if the company decides to produce only 3,000 containers of new extra crunchy peanut butter, how many containers of regular crunchy peanut butter would it produce? Remembering you don't have to use a tape diagram at this point if you know that the 3,000 containers of new extra crunchy peanut butter would be 5. So 3,000 divided by 5. And 3,000 divided by 5 equals 600. So if 3,000 divided by 5 equals 600 in each piece, 600 times 4 is 2,400. And that's how many regular crunchy there would be. And that's where I got 2,400 from. Or 2,400. Both of those are correct. So, hopefully you remember how to divide, and you remember how to do this type of multiplication, because these are 2 operations you need to do to complete some of these problems. If you are struggling with division or multiplication, you certainly need to see myself, Ms. Shaw, or another teacher to get some extra help on this, to do some extra work at home. You can also go online and review how to do division and how to do multiplication. That will help you as we continue on. Let's review what we learned today. For a ratio A to B, remember we talked about that. A is any number, B is another number. We are often interested in the associated ratio B to A. That's the flip-flop of that. Further, if A and B can both be measured in the same unit, which means they're both inches, or they're both feet, or they're both yards, or some measurement that's the same, we are often interested in the associated ratios A plus B and B to A plus B. For example, if Tim caught 3 fish and Kyle caught 5 fish, we can say the ratio of the number of fish caught to the ratio Tom caught to the number of fish Kyle caught is 3 to 5. The ratio of the number of fish Kyle caught to the number of fish Tom caught is 5 to 3. That's this piece here. It's A to B, B to A. It's just flip-flopping. It is not the same, but you can take a ratio and turn it around and change what you're saying about it. The ratio of the number of fish Tom caught to the total number, this means the total number, the total of it, to the total number of fish the 2 boys caught is Tom was 3, and the total number was 5 plus 3, which is 8. The ratio of the number of fish Kyle caught to the total number, Kyle caught 5 fish, so it's 5, to the total 8 plus 3, 3 plus 5, which is 8, sorry. So we learned all that at the beginning. Then we learned that the ratio of A to B, where B doesn't equal 0, the value of the ratio is the quotient, also known as a fraction. And the reason why we can call it a quotient is because a fraction bar means division. So for example, the ratio 6 to 8, for the ratio 6 to 8, the value of the ratio is 6 to 8. And then once it's a fraction, we can simplify it by dividing top and bottom by 2 the numerator and denominator by 2 and getting 3/4. That's where that came from. So that's what we've learned today. Now it's time to go to the exit ticket. Lesson 7 exit ticket starts with, Alyssa's extended family is staying at the lake house this weekend for a family reunion. She is in charge of making homemade pancakes for the entire group. The pancake mix requires 2 cups of flour for every 10 pancakes. So the first thing you're supposed to do is write a ratio to show the relationship between the number of cups of flour and the number of pancakes made. Number 2 says, determine the value of the ratio. Number 3 says, use the value of the ratio that you just determined to fill in the following 2 multiplicative comparison statements. Remember, don't let that fool you. That just means you're going to see an of in the statements. The number of pancakes made is blank times the amount of cups of flour needed. The amount of cups of flour needed is blank of the number of pancakes made. If Alyssa has to make 70 pancakes, how many cups of flour will she have to use?